welcome back to Physics in the Flesh. We are starting a new section on magnetic fields, Magnets and Electromagnets 1. Describe how you would use the right-hand rule to determine the direction of the magnetic field around A long straight conductor with a steady current, B, a loop of wire with a steady current, and C, a coil of wire with a steady current. So let's figure out what's happening with the straight conductor first. So what I've done here is grabbed my headphone wire. Okay, so for all intents and purposes, let this be the straight conductor. Okay, now assume that the current is going in this direction. Okay, now if the current's going in that direction, what I do for the right hand rule is I take my right hand and my thumb points in the direction of the current. Okay, so my thumb points in this direction and my fingers are supposed to curl in the direction of the magnetic field. So notice they're going under and over towards me. So thumbs pointing in the direction of the current and fingers curl in the direction of the magnetic field. Okay, so now let me attempt to draw this. So for part A, here is your long straight conductor. So any wire will do. And you've got the electrons in this wire. And of course, we're told that the current is going towards the right. Now, for your hand, okay, again, don't laugh as I attempt to draw this. Your thumb points in the direction of the current, and then your fingers curl around in the direction of the magnetic field. Okay, so there's one finger. There's your another finger. Oh boy. Here's another finger, and here's another finger. Okay, and they're connected like this. I've always thought that they should send physics teachers to art camp to learn how to draw, but okay, you'll have to deal with that picture for now. So there's my hand. So look, thumbs going in the direction of the current, fingers curl around in the direction of the magnetic field. So if we actually draw this schematically, this is how it's going to look. So there's your wire. Here are your electrons. Your current is going towards the right. So my magnetic field is going under the wire and over, under and over, under and over. So there is the direction of the magnetic field. Okay, so hopefully part A makes sense. Now part B, a loop of wire with a steady current. Now I'm going to attempt to demonstrate this with my headphones again. So here we go. So here's my loop. Now it's the same principle. Let's say the current's going around the loop like this. Take your right thumb. Your right thumb always has to point in the direction of the current. Now, if the current's changing direction, my magnetic field, notice it's always going under and over as you go around. I know it's a little hard to see, but try to visualize that. It's going under and over, almost like when you have a boiling pot of pasta in the water comes out from the middle, goes out towards the outside. That's essentially what's happening here. So let's draw what's happening. Okay, so you've got a loop of wire, so something like this. And we've got the current also moving through that wire. So just draw in your electrons there. So remember, the direction of current is defined as the opposite direction of electron flow. Since back in the day, everything was, I guess, theorized based off a positive test charge, which means, so we'll let the current be coming in like this, and it's going outward. So around the loop, we've got the current going in this sort of direction. So again, you take your thumb and you take it around. Okay, now magnetic field, like I said, it's like a pot of boiling pasta. You've got the magnetic field coming out underneath and coming out from the top, going towards the outside. Okay, so your magnetic field actually ends up looking something like this. So under and over, under and over, under and over. And the same thing here. Now at this point, it's a little bit hard to draw, but it's going under and over again. Under and over. Okay, so this is how you sketch the magnetic field for a loop. Now the last part is probably the best example here. Okay, I'm not going to show this with my wires, but assume you have a coil of wire. Okay, so like a solenoid. Okay, so you've got something that looks like this. Okay, and the current is actually going through this. So if you remember, I don't know, actually, maybe you don't remember, you're too young. But the old telephones used to have coiled cables like this. It used to look like that. So that's their direction of the current. And it's funny, the right hand rule works in both ways. If your current is going straight, the thumb becomes the current and the fingers curl in the direction of the magnetic field. However, if your current is the one that's going in a curling fashion, then now your fingers represent the direction of the current, right? So in this example, the current's actually going like this. It's actually going around. So therefore now my thumb represents the direction of the magnetic field. Okay, so the idea is that both of these, the magnetic field and the current, are perpendicular to each other. So if one of them's looping, then you use that as your fingers. If one of them's going straight, you use that one as your thumb. They will never both be going straight. You won't have one magnetic field straight and the current straight. You'll always have one in a loop. So, okay, and that's it, guys. I hope that was clear. I know it was probably a little bit hard to see with the video, but just practice that. The one that's going straight is your thumb, your right thumb, and the other quantity is going to be represented by the direction of your fingers curling. Okay? So that's it for this video, guys. Be sure to smash that like button because I'm sure you completely understand this concept now. Just practice it at home with some wires around, like the wire for your mouse or something, and I'm sure you'll get it in no time. If you have any questions, be sure to leave them in the comment section below. Otherwise, I will see you guys tomorrow at 12 noon for the next video. Stay tuned tomorrow for video 170, Magnets and Electromagnets 2, where we will examine how a doorbell works with an electromagnet.